Good morning, grade 4ers. How are you today? Today we'll complete our lesson, How Do Scientists Answer Questions? Today is Wednesday, 8 April 2020. All of you open page 320, 321. Learning objectives. To know some different methods scientists use to answer questions. Today we will study about the models. This is a model of river. Sometimes scientists want to test things they cannot test on actual objects. So, a model is a version of an actual thing that scientists can easily observe. It can be drawing, a computer program, a three-dimensional object, or an idea or description. This picture is a model of river. This is a model of river. It allows scientists to observe things that might be large or take too long to observe in natural environment. Look also at the picture here. This is the largest moving model of Earth world. Now, sometimes, as I told you, scientists want to test things they cannot test on actual objects. For example, a scientist might want to know how strong winds affect an airplane. So, the scientist can test a model of a plane using wind tunnel. Now, models are objects or ideas that represent other things. They may show how something is made or how it works. Now we have three-dimensional models. The model of Earth here at left is a three-dimensional model. What is the meaning of a three-dimensional model? Describe objects that have length and width and heights. Models are not exactly the same as real thing. It's not exactly as real thing. So this model of Earth shows the location of Earth land and where is water, but does not show what is inside Earth or features made by people. Who can read for us this question number 11? What are two other examples of a three-dimensional model? A diorama of a forest, a model of an airplane with moving parts. Now, also we have two-dimensional models. Some models are only two-dimensional, describe something that has length and width, but not height. Two-dimensional models are flat, like the map here. A map is an example of two-dimensional model. Now here, question number 12, draw a two-dimensional model of your classroom. I want you to draw your classroom, two-dimensional model. Now, explanations. A hard surface makes the ball bounce higher. Now, explanations answer scientific questions. Explanations might support a hypothesis. They might also disprove a hypothesis and suggest another one. So, after scientists design their experiments and run trials, they use evidence to explain the results. The explanation should answer the original question the experiment was designed to ask. And the explanation will also tell whether the hypothesis was supported by data. An important thing to remember is that a hypothesis is a possible answer to question. Now here we have question number 13. What was the hypothesis in bouncing ball experiment? Did the data support the hypothesis? Can anyone answer this question? The hypothesis was that the ball would bounce higher on a rubber surface, but the data did not support the hypothesis. Now go it. Name 3 methods scientists might use to investigate a question or problem. What is it? They may do experiment, build a model, or do a survey. So again, number 1, experiment, build a model, or do a survey. Now question number 15. Why do you think evidence is important in science? Evidence is important because others can make the same observations to find out whether a hypothesis is reasonable or not reasonable. Now I want to show you here a model of river.
Hi, my name is Mrs. Shanath from Skyview Elementary. Today we will explore how models help us to learn about natural formations such as rivers. It is important to know how to study nature using models because although we cannot always see a river, stream, or lake in its entirety, we can use a model of it to help us become familiar with what it looks like. Have you ever been to a river? By visiting and observing a river, you can tell things like color, clarity, depth, and width.
This is a model of river.
However, can you tell how that section of river compares to the sections upstream or downstream from it? Can you tell how wide it is at that point in comparison to where it begins? Can you see what the source of the river looks like? To get a larger idea about the details of the river, we could use something like this. This is a model of the Rio Grande River. By observing this model, we can tell the relative width of the different sections of the river. We can use it to show what the banks of the river might look like in different areas, or what types of vegetation might grow in or around it. We can see the river in its entirety, from the source to the output. What are some problems we might have with studying a model? Can you tell the depth of the river by looking at this model? Depth is difficult to show in a model. Another problem we might have when studying a model is accuracy. It is difficult for a model builder to build exact specifications of a real river in every area. It is more beneficial for us to think of models as a representation of a real river rather than an exact replica. Even though models have their limitations, they are still a very helpful way to add to our knowledge of natural formations on Earth. In today's video, we looked at a model of a river. We discussed how models are helpful and also some limitations a model might have. You try it. Using clay, do some research on a natural formation like a river, stream, lake, or even a fossil bed and build a model. Remember, you are building a representation. It does not have to be perfectly accurate, but it is helpful to make it as close to actual specifications as possible. If there is space in your classroom, display your model and present it to your classmates. Until next time, I'll be seeing you.
Okay, thank you, my dear students. And we will take a new lesson, inshallah, next week.